Hi guys! So, my name is Italo and I'm developer circles organizer here in São Paulo. I'm Microsoft MVP in AI category. And today I'm work as a solution architect at Vortex FinTech, and I'm a dependent consultant in Italo.js Enterprise 2. So, I'm a Brazilian developer, and today I will talk about how to extract my skeleton and segment my body use a simple picture. So how I can segment my body, use a simple picture, take it from my iPhone, take from my Android, and how can I do it from the browser using my webcam. So we use the TensorFlow.js. TensorFlow.js, it's a wrapper from TensorFlow that is a deep learn library. And we have some projects using these libraries. For example, the BodyPix. The BodyPix is a project that we can do some things like segment your head, segment your body, your hands, your foot, and we can extract our skeleton with this library too. And know our positions and make application with this. For example, as you can see here, a blur of humans in webcam. We can do other funny implementations too, like draw, make animation using your body, or just to blur your screen when you got a wrong position. Yeah. So how we can do it, it's the most important of presentation. So we will build a JavaScript application here. Any framework, it's just a clean and vanilla JavaScript. Okay, so to start, we need to import the TensorFlow.js and the BodyPix library. Okay, and we do it with just with the CDN link in my head. Okay, so after that we create in our BodyPix image tag with ID and with my picture. Okay, and in my script I just get my image with my by my ID. Okay, so I load my model with BodyPix, and inside this method we have we are loading a network. Okay, a deep learn model that we can choose the architecture. If you don't know about deep learn, don't worry. Okay, it's a super high level library, but if you understand about deep learning, you can configure it a little bit. So we have an architecture. We can choose by MobileNet or ResNet. MobileNet is architecture to run in devices like a Raspberry or a mobile, and we have the ResNet that are architecture for run in robust machines. We have another option that is output stride. It's about your output resolution. Okay, we have a multiplier. This multiplier is used only by MobileNet, and this value is about how much convolutionals you want in your MobileNet architecture. Again, if you don't know about deep learning, don't worry, you can use this library like a developer engineering. So and we have a quant byte is so much bigger is your model. So with so much bigger your quant bytes property, most precise your result. Okay, and after we load our model, we just call the segment person passing an image as a parameter. So we can pass an image, and we can pass an optional argument like flip horizontal. For example, if your webcam is flipped, okay, internal resolution. So we have super resolution image, a 4-key image, and you want just predict a simple person inside this image to get the head information. And if you have a big image, you will have a big processation, you know? So for this, we choose the internal resolution that the BodyPix will get this image and will resize it for a medium quality, high quality, or full quality. That full quality is the original quality. And we have the segmentation threshold. The segmentation threshold is uh, how much percentage you want the AI, the deep learning model, find a person. For example, okay, I got this object, and this object has 50% of be a person. No, I don't want this object. I just want objects that has 70% to be a person. You know? So this is the full code. This is the basic code, and we have here just the load your library, load your image, and just predicting our segmentation person. And inside our segment person return, what do we have? We have this object. It is an object containing all poses, you know. So all poses is like all persons inside your image, and we have there the zero position containing many key points. And what do we have inside the key points? Inside the key points, we have, for example, the part of my body. So I have my nose, and my nose is positioned at in X position 314, and my X position in 78 pixels. Okay, this metric is in pixels. And we can just print this information in my webcam in front of my image, or I can just got information to do some some application. Knowing my news, I can just ask for the user to go to the left or go to the right, and just verify if the user are possessing it in the right place, you know. So but how we can observation, this method just segment one unique person, okay? And how we can segment multi person inside our image. So I can use the segment multi person method, okay? And in this method, we have another properties like the free horizontal internal resolution, and we have max detection, how much people you want to detect inside your image. And we have the score threshold is the same thing. It's a little bit different, the threshold, the previous threshold, because this threshold is related by connected parts of my body. So I want to connect my body, I want to connect my my hand with the rest of my body when this part has a 40% of be connected. You know, we have this NM's radius. It's related about how much you want to suppress, you want to have a shaped body segmentation. And we have the mean key point score is how much key points I want to detect to say, okay, this is a person. I have a person here. Okay. And we have our last option that is refine steps. The refine steps is how much prediction you want to do as the same image and to get a better result, you know, because when we are working with deep learn, when you put an image into predicted, the result not necessarily will be the same in the final. Okay, so what this will result. The result of this method will be an array with many persons, okay? And each person, we have here the 0, the 1, the 2, and each item inside this array, we have the data property. The data property is your image in pixels, okay? So it's a big array containing any properties about your pixels and what part of your body is inside there that pixel. We have the height and the width, the size of your image, and we have the pose that has explained in the previous slide. It's just to remind, the pose is this object. We have all key points inside, okay, and we have a data, a height, a width too. So um, and how we can visualize these results, how we can manipulate this data to visualize what is happening with my data. So I can segment it. I can just draw a mask inside my person. I'm not segmenting my body here. I just segmenting my person. It's different. Just remember, just note it. And here we have another code that we load the image by element by ID. We load our BodyPix, and we call the segment mode person pass an image. Okay, so I just call the method to mask, passing my segmentation. This object is the same object that we saw in previous slide, and my mask contain a mask, okay. And we can call the draw mask method, passing as argument my canvas to draw it in the browser, okay. Or if you are working with React, Vue.js, or some Ionic, Angular, or something like this that works in a mobile, it will work, okay. And this is awesome. So we have the canvas, our image, okay. Our image can be our video, and we will see it in our demo. We pass our mask, some opacity. So this opacity is about how much you want to opacity your mask, okay. So you want super blank mask, or you want some transparent mask. We have the next parameter is the mask blur amount. So it's about how I want to blur my mask, and the flip horizontal if my webcam is flipping my image. Okay, so how we can get colored visual result and segment my body different for this image to this image, how we can get it. So we can use the same quite the same code, okay, but we have some difference here. The first one is the segment mode person parts. Parts is super important to remember, that we will got a segmentation of my each part of my body, and we have our mask. We need to use another method that is to colored part mask. Okay, it makes sense. So here we got a draw mask method with the same parameters, and here we will got the result of my parts of my body. And what I can do with my segmentation, here we have an example when I just segment my body and not segment my body part, segment my all body, So what I can do with this? I can make the blur effect that the Teams, the Skype have, and the other video conference platform use. I guess they Zoom use it too. But how we can do it? We have an element, okay, element image. We have our network loaded by BodyPix load. We segment a person, a unique person. It's not segmenting mood person and not segmenting my body parts. Okay, so I just draw make sorry I just call the draw broken effect method, and I pass my canvas, my images, and my segmentation, my background blur amount, my edge blur amount. This is important because the edge blur amount is a little bit different from previous slide. This edge blur amount is how much blur how much shapeness you want your background having around your body, you know? And the flip horizontal if your webcam are flipped. And what we can do with segmentation parts, we can blur our body parts. And what we can blur? We can blur our face, for example. So it's just remember, it's just a example. You can do so much things. Your creative is the limit. Okay. And how we can do it? I did this at this time. I will use the segment multi-person parts. It's important to note because it's different for segment person. Okay. And I have here a different parameter. Is the body parts ID to blur. So I choosing the 0 and 1 parts, but I can choose any parts, and you can check the documentation for know what numbers, what is the ID of each part. And here I'm blurring my left face and my right face. Okay, so I just ask for the BodyPix blur a body part of my image. Okay, so I pass my canvas, my image, and uh, all these arguments that you already see before. Okay, so let's go to the demo. And what we will do in this demo? We have a simple demo here, and we will just blur my face when my hand is inside my hand, you know? And we can visualize too my segmentation. So I will just get some space here. I'm I'm printing my I'm printing my hand and my left and right face. Okay. So when I do it, when I intersect my hand with my head, I will blur the image, and we can just print our key points too. And this key point is our skeleton, you know? So I have my face here, I have my body here, okay, you know, as you can see here. So how we can do it with JavaScript to run in browser and vanilla JavaScript. So we have a code here, and we have HTML, CSS file, and a JS file. Okay, I don't will explain the CSS because I guess the most important here is the JavaScript. In my HTML, it's a simple code, as you can see here. We have my libraries import by CDN, you know, I'm importing the Tensorflow.js and my BodyPix. Okay, so I have my canvas to draw my modified image, and I have my video. Okay, so I have a dashboard just to contain some checkboxes like segmentation mask and detection mask, detection point. Sorry, just to you visualize it, we have our checkbox here, okay? And here we have my canvas and my script detect.js. What do we have inside the detect.js script? So we have some selectors. I have my video, I have my canvas. I create a context for this canvas, okay? And I have my two checkbox. So I'm just defining some configurations for my video, and I set the canvas to have the same size of my video. So I call the navigator my media device, and I get the user media past my video configuration here, okay? And when the stream start, I will fill my stream in my video, okay? It's not new here, okay? It's a simple thing. So we have here the playing event. When my video will start to play, I just will load my BodyPix model, okay? I will set my canvas to block, and I will start to predict it. So I will got an image, and I will make a prediction here, just to verifying if my hand is in front my head. So if true, I will just blur my head, okay? So it's super important. For example, in events, you can just make an application to detect some QR code in front your participant, so you can read this QR code. If your attendee don't permit you to take a picture from here, you can just blur that face. It's awesome for event organizers. So in my predict method, it need to be async, okay? Because this process is a little bit high. It have a high processor, so because this we need to work async mode. And to load a video, every video project that you will work will have this while true, okay? So it's not a bad pattern. I know it's a little bit strange, but it's the common uses of when you are working with videos. So here I get a segmentation. So I'm working with only one person, okay, in front of the camera, and I just call the segment person's body, okay, and I pass my video. It's different from the slide because here I'm working with a video. I'm not working with an image, okay. So I just pass my video here, my global variable video, okay, to my BodyPix method, and the BodyPix can handle it very well. So here I just check if segmentation outpost 0. So if we have some pose inside our segmentation, okay, I just continue because I don't want to process all my image if I don't have any person in front of my camera. So I have the method draw. So if I detect someone, I just will draw it, okay? And inside this method, I have this code. I check if this show mask checkpoint is checked. So I just show my mask, okay? So if I have the show points checkpoint checked, I will print my key points, okay? So in the first condition, I will get my person segmentation for this variable, just to don't work with reference here. I will get my data, and I will fill the data property with a filter. So what I do here, I have a segmentation of all my body, and I need to filter my hand and my head. So here I go to the data property, and I iterate of each pixel, and I check if the ID of this pixel is 0 or 1 or 10 or 11. So here I'm filtering for my lefty face. Here I'm filtering for my right face. The 10 and 11 IDs is about my hands, my right hands and my left hands. So if not, I just return a -1 to it don't have anybody parts, So if true, I just return the value. Okay, here I have a new segmentation that are filtered by my hand and my face. Okay, so I just call the two colored part mask. because the BodyPix will return an image, okay, that are coloring my head and my face. So I just ask for BodyPix to draw to draw a mask um, involving my hand and my face. Okay, so and why I do this filtering, because in the filtering I will need um, to verify if my hand is intersecting my head, you know, because this I'm not asking for BodyPix to filter it, and I'm filtering it in myself, you know. So else I just will clean my context, you know. And if my show point checkpoint is checked, I mean, if you asked for show the key points, I just will verify all the pose of my person segmentation, and for each pose, I will call the method draw key points, passing my pose key points and passing a threshold. Okay, and this method, I just iterated for each key point that I have. Okay, I check if my key point score is less than mean confidence. Okay, and I just print it in my context. It's simple. Okay, it's simple, but we can get this information to do some applications like um, grow up your hand, um, grow up your hand, your right hand, or grow down your left hand, and something like this. You can get this information of the person position using the key points, you know. Here I'm just printing it. So after that, after the draw method, I just got the verification if my hand is in front my head, you know. So I just verify if the show mask and the show points is checked. If true, I just continue it, because I will draw these guys. But if not, I just to continue the code, and I do this thing. I got some parameters here, okay, like a face threshold, the first pose. Okay, remember the here I'm working with unique person in front of the webcam. So I got the person in index 0. So I got the nose, the left eye, and the right eye. Here I just want to check if I have a face, okay, using the key point. I can implement this in another way using my segmentation, but here I'm just in want to show you how you can use the key points to work and make some applications for you, you know? So I check if I have a face. So if I have a face, here I'm filtering again. I'm filtering my segmentation to filtering my left face and my right face. Okay, so just remember the data property is a big array, and in this big array we have the ID of each body part inside inside each pixel. I guess it's a little bit hard to understand at the first time, but here we have all IDs detected in an image. So here I will have a face array, and I do the same thing for hand array. Okay, so I just convert this array for a matrix, because I need to use this matrix for detect if my hand is in front my head. Okay, so I will compare two metrics. Okay, so inside this method, we have just a complex method that I guess is not important to explain right now. But here I'm just splitting array inside a matrix, you know, by a limited size. Okay, so when I iterate by my array, and when I got my limit size, I just crop this array in a new array, you know. Okay, so after that, after convert my array, my data array, my body IDs array to a matrix, I just intersect it. So I just pass for intersect method, face matrix, hand matrix, and how much pixels I want to be intersected. Okay, so inside this guy, I iterate by face pixels. Okay, so I iterate by face pixels in x axis, and I check if my face pixels is about some body pix, you know, because when we have -1, it's mean that we have a black pixel, you know, like we don't have any body parts there. So if I have something there, I just iterating by uh, some some pixels, you know, like here I had my padding. I iterated by some block of pixels, and I check if my hand pixels at the same position is greater than -1, or it's my hand pixels in the same position but in this block part is mine is greater than -1. So it's significant. It's mean that we have a score of my intersection. Okay, so here I just to check if my intersection is greater than 10%. So if true, I just blur my face. And how we can do it, you already see it in the slides. So we have my body parts, the left face and right face. We have our blur amount, how much I want to blur my face. Okay, my edge blur, so how much I want my edge are blurred. And I ask for BodyPix to blur my parts, passing my video here. Just remember, we are working with a video here, and pass my canvas and all parameters as you already said before. Okay, so in the final, we have this result. Okay, so I just check if my hand in front my face. I can use other information to blur my face, like a QR code or like some other input. I can segment my body. Here I'm filtering my hands and my head, but I can just print all my body. Okay, and I can detect my key, and I can show my key points just to get some information. For example, you want to make a yoga application and you need to know the position of the persons, you know, you will use the key point. And so I guess we can go to the Q&A session. And thank you very much by your presentation here. And any questions that you have that you don't think in the Q&A session, or you can't do right now, you can just contact me at my social media, and I it will be amazing to talking with everyone about your questions and help you in your projects. Okay, so thank you very much, guys.
So we're waiting for a few questions to come in from the audience, but I do have one or two that I jotted down if we're happy to dive into those. It sounded both a complex and a simple project to do, if that makes sense. It was a complex thing you were trying to achieve, but it sounded like it was fairly easy with TensorFlow to get it up and running. Is that fair to say?
Sorry?
So doing exoskeleton mapping is a complex thing to do, full stop, really, isn't it? And it seemed like TensorFlow made it much, much easier than it could have been.
Yeah.
Have you got anything to say on that?
Yeah, the TensorFlow is focused in two publics. We can use the TensorFlow 2.0 that is more focused in the developer, the developer experience to build applications done with no deep learn, and don't need know the math of deep learn, don't need know how you can architecture a deep learning model. But if you are a data scientist, you are a researcher, and you need to build a model from scratch, you can do it with TensorFlow. And today we have the TensorFlow, or the original TensorFlow is in C++, and we have a big wrapper in Python. And these two versions is the most complete versions and is most recommended for that researchers and data scientists to build your model from scratch and build complex model, And we have another options like Tensorflow.js that you can build complex model too, but it's not super covered like Python or C++. And the JavaScript, the TensorFlow in JavaScript have some high-level package to work with some pre-built models, So it's interesting to, when you are working in a team that don't know so much about data scientists and you want to make some application, some cool application that use deep learning. So you can use the TensorFlow.js, the pre-built models from TensorFlow.js.
Okay. Have you got any experience of other ML libraries, or is TensorFlow your JS
for me,
experience?
the TensorFlow, we have another libraries in JavaScript too. I don't remember the name right now, because in my previous 2 years working with computer vision, I just worked with PyTorch and TensorFlow. Okay. But the TensorFlow and PyTorch is the most complete libraries focused in deep learn, and the TensorFlow it's more near from the not data science developer.
Okay.
The PyTorch is a little bit focused in research, so it's in Python, don't have a JS version, and it's to build complex and robust deep learning models. And the TensorFlow it's divided in researchers and developers. So today we have another libraries to work with computer vision and work with machine learning, but all libraries is built by the community. And the most robust deep learning library that we have today is the TensorFlow. It's for JS,
Yeah. Is that just because it's used so much, that's why we've got more models to go with it?
TensorFlow you can just go in the TensorFlow hub and check for the pre-built models, that pre-trained models, download it and use it. For example, here I'm using the BodyPix. The BodyPix is a library that use the TensorFlow. But you can use the TensorFlow, download a model from TensorFlow hub, load it, and put an image like input and got your output. And it's awesome because it's run in JavaScript, but you can use a pre-trained model from Python and convert it for JS. So when I was working with TensorFlow.js, I have two quite 2 years of experience with TensorFlow Python and 6 months working in one project with TensorFlow.js. And it's awesome because you can train your model in TensorFlow Python and you can got all the resource of TensorFlow Python and you can just got your final model, convert it to JavaScript and consume it in JavaScript, you know? So you can just make some easier API or use some developers that don't know Python, just know JavaScript to build applications that use a model that was trained in Python. So, sorry.
No, don't worry.
It's super hot here in Brazil. I guess it's something like 30 degrees.
Wow. Wow, that is quite hot. No wonder you are sweating profusely at the moment.
And it's 7 p.m. right now.
Oh, nice. Well, for comparison, in my office under the studio lights, it's only 23 degrees here, unfortunately.
Oh, it's awesome.
So we had a question come in then.
Awesome.
Is it possible to start using this without spending tons of time on learning documentation and how it works under the hood?
Okay.
Do you need to understand the detail in order to get something out of?
Yeah, it's the most amazing part of TensorFlow.js because we have two versions of TensorFlow, the 1.x and the 2.x. So when the TensorFlow become in 2.0 version, it was focused in non-data scientist developers. So if you don't know nothing about data science, you can use these libraries. You can use the TensorFlow.js because the TensorFlow.js has a great support for that developers that don't know about data science and don't want to know about data science. So if you know a little bit about this area, it's good because you can configure your model, you can configure the parameters. But if you don't want to know, you can use the TensorFlow.js in a simple way. And it's in JavaScript version. If you are using it in Python version, you can, I guess you will need to know a little bit about data science.
Okay. And let's say, so this is a question for me now because I'm interested in this.
Sure.
Let's say I want to have a play around with it. Do you have a suggested project that I could start with? Is there, because computer vision is very difficult and probably not the best place to start with something like this, I would imagine. So where would you suggest?
Sure. I have the first suggestion is working with classical computer vision. For example, it's not necessarily use deep learn, but just using processing images or computer vision using OpenCV. You know OpenCV?
No, I don't.
No, OpenCV is a library built by Intel, and I guess it's the most famous. It's the most famous library and the most complete library, again, for high-level developers and low-level developers. So starting with OpenCV, you will learn how we can manipulate a video, why we use a while true inside a video, how you can crop an image or do something like this, because it's the base for understand how the model will consume your data and you will get an output. So understand how is the data of an image, what is the RGB, and things like this. So I guess the first step is learn OpenCV. So with OpenCV, you can learn in low level if you want, or if you don't want to learn computer vision in low level, you can just load it in high level. After that, you can start with the deep learning models. Again, if you want to learn this in low level, it will be a little bit hard because you will need to be a data scientist.
Yeah.
But if you don't want to do it, you can just use the TensorFlow 2.x, 2.0, 2.1 that has somewhat pre-built models and have an easy interface to developers. You know?
Yeah, and I think that'd be a good thing, not just for me, for everybody to do. This necessarily isn't a technology we can use day to day. Certainly not for me, but it is probably something I should know about for when I can.
Sure. I guess for me it's super important because, for example, have some tools that we can build for our life that we, if we don't know about these topics that we don't use it a day, we can use it. For example, here in my house, I have some difficulty to receive some packets. So I have a camera in front of my house that just analyzing if my FedEx car are arriving, and if true, I receive a message in my phone. You know.
Brilliant.
So no, these technologies, I guess, is not a day-to-day technology that we use, but we can do so much funny tools for us, you know?
Yeah, I think where I'm going to start, and tell me if this is a silly idea or not. We've got 2 cats that visit our house. One of them we feed because he's the neighborhood stray, and one of them who just comes around for strokes. If it's the one that needs feeding, we've got to go out there. But if it's the one for strokes, it's not so important. So maybe I could set up a camera like you and get a text message when the cat needs.
Yeah, you can do it. For example, with the TensorFlow 2.0, we have in the high level layer, we have a technical called transfer learn. So we have a built model that can detect many things, can detect animals, persons, can detect cars. So you give 200 image from this cat, and we have, so the TensorFlow will do a transfer learn from this image for this model. So we have a model in the final. We will have a model that can detect objects and can detect your cat, you know?
Yeah. I was talking to someone not too long ago, and they said that when you're building up your data set for this kind of thing, you need to be really careful about what's in the background as well. So, for example, you need to be careful of what's changing in the background of the image, because the cat might be the same, but if it's in the same spot from the same camera and the background's changed, it might be picking up the background. Is that true, or does he not know what I'm talking about? Or do I not know what I'm talking about?
It's depending of your implementation. For example, if we are using object detection with deep learn model, the deep learn model can work with many contexts. So it's don't matter if you have a background, a complex background or a simple background, but if you are working with classical computer vision, you will need to pay attention with these things. So the difference between classical computer vision and the deep learn is exactly this. In computer vision, is super much faster to implement the projects, and it's super most simple to implement the project. But it's don't work in every context. You know, if you have image with many cats and your cat's in the front, the computer vision maybe it's not will detect your cat. But if you using deep learn, you have image with many cats in the road, many cats super similar with your cat. The deep learning will detect what is your cat.
Okay, I've got a feeling you're going to get a message from me very soon with 200 photos of cats attached to it saying, why doesn't this work? At that point, I'm going to say thank you very much for joining us for this Q&A. We are
you're
out of
welcome.
time now. And thank you for the amazing talk. I certainly learned a lot. I'm sure everybody watching did.